So I get text messages all the time about whether I can turn something in late or not. Yeah, you can. Remember the online students, I give the extra 2 days grace periods, because to make up for the fact that you couldn't watch the video. So that's okay. And if there's another reason, then let me know about it. But particularly when you're uploading the assignment, there's a comment field. Just go ahead and put a little comment here. All right, I had to work overtime, or I didn't understand it, or I talked to you and I came for tutoring, something like that. And by the way, we have a good tutor, programming tutor, who I'll post the information for so that you can attend to him. Anyways, so where you upload things, you see that comment field. Even if you've told me and we've exchanged email or stuff like that, just put the reason there to remind me, right? Because I can take that into account. The first half of the class, the first unit, I'm not super duper hardcore on the due dates. So, if you're a little bit late, it's not going to crush your grade. But after the first unit, then we're going to stick much more tightly to them. Just let me know in the comment field why, because if you're struggling with something, I need to know about it. And if it's time constraints on your end, that's also useful information. Especially if a lot of people are falling behind, then I know that I've set the schedule a little too aggressively, right? So you got to let me know. I think we've actually gone to chapter 5, had we not? Yep. So iterations. We talked about 2 ways of leaving a loop. If you're inside a function, you can leave a loop with a return statement. If you're not inside a function, right, if you've just typed code and there's no indentation levels at all, there's no such thing as a return statement out of there. You could issue an exit call and kill your program, but that's probably not what you want. But you can break out of a loop. So break works like this. Even if it seems like it's an infinite loop, like while true should be an infinite loop, once it finds a break, it skips to the end, the first statement after the while loop, and executes it. And so this is a common way to avoid what's known as a priming read. And priming reads are when you ask for data to begin with before you enter the loop, and then you have a while loop, and then you ask the user again for more data. So you're asking for data in 2 places rather than 1. Kind of like this. Kind of like this. Say I was going to write a program to add up numbers. That kind of thing. So, I would do something like this. X is equal to input score question mark. Or -1 to quit. And then we'd have to convert it to an int or a float, right? And then after that, while x is not equal, and I need to take the parentheses away. That's not necessary for this language. Won't kill it. While it's not equal to our killer death value, our sentinel value, then do the stuff, right? Add it to our total or whatever. Total is equal to 0. We could put that above that to make it look a little bit prettier. Declare our total before we ask for input. Then we add that to our total. Total equals total plus x. Then we get a new value. We ask them again. This is how you construct this thing without a break statement. And that works. This is what's known as a priming read. I have a personal distaste for priming reads because I think that at any time you have a copying and pasting of code, and you saw me do it, I copied and pasted the code, then that's not a good thing, because we have the same code in 2 places. And what if we make a change somewhere and we forget to make the change somewhere else? Like, this while loop could be 200 lines long before we go down here and we see the next time we get the input. And what if later on somebody tells us, oh, well, it really should only accept ints. And so we change it in one place, but we forget to change it to the other. Or they want this message changed, right? but we only change it in one place, not the other. That's the peril of having duplicate code, copy and pasted code, is that you have to make multiple fixes for it. So the way you avoid that, one of my messages disappeared, several of them. The way to avoid that is with a while true loop and then a break statement in it. So I'm going to do the same thing. I'm going to set total equal to 0. And by the way, I don't care if you're typing this or not. What I mean by that is this is stuff you could just learn visually, right? While true. In other words, repeat this endlessly. Then x is equal to input, score or -1 to quit, right? And then we check right there. Whoops, except that was supposed to be a float. I deleted that while I was talking about making changes to it. Okay, then if x is equal to our sentinel value, the value that's supposed to cause us to quit, then we're going to break. If x equals -1, colon, break. Not Barack. There we go, break. Otherwise, keep doing our stuff, right? Total equals total plus equals x, or total equals total plus x, right? To me, this code, not only is it shorter, but I think it's simpler than this, in my mind. That's the way my brain works. Nothing wrong with doing it like this. But in some places, you'll be iterating through stuff where you don't have a chance at getting a priming read done. When you're stepping through a list of data. Not that we've talked about lists yet, but you've probably seen them in fundamentals. If I do this, if I make a list of some numbers, 8, 6, 7, 5, 3, 0, 9, like that, and then I want to iterate through them, I wouldn't use necessarily a while loop. I could, but I could also use a for x in L. What this means is for every number in that list, do something, add it to the total or whatever. But what if we were looking for a -1 or we wanted a special sentinel value in there to trigger something? Well, you can't do a sentinel read before your for loop and then do the same thing inside here. It would all have to be in here. So I like to try to train people away from doing the priming read, even though that's what the textbooks tend to show. But we're better than the textbooks. Especially better than the fundamentals textbook. We're beyond that now. So you can fit it, just like the break statement, you can use continue. And what continue does, well, what break does is it causes it to go to the end of the loop and exit the loop. What continue does is it causes it to go back to the beginning of the loop. So I could do something like this. I'm going to delete this stuff about the list if you don't mind. I could write some kind of loop. X is equal to 1, while x is less than or equal to 10. And then if x is equal to 5 for some reason, I don't want to do anything. I'm just going to skip the idea if the x is equal to 5. But in other words, after that, I want to print out x. And then add 1 to x, because if you do not update your loop control variable, then it's an infinite loop. So what this would do is this would print out all the numbers between 1 and 10, but it would skip 5. Why? Because when it hit the continue loop, it's going to run back up to the top of the loop. Actually, that's going to be an infinite loop. It's going to count 1 through 4 and then never continue. Continue is the wrong word. It's going to hit 1 through 4 and then never advance. Why? Because continue is going to cause it to always go up here, never get to here. So that's a problem. So if I run it, it's going to run part way. It's going to ask me for some scores. I'm going to wind up commenting out the input statements. Which lecture are we on? We're on H? Yep. All right, so anyways, when I run it, yeah, -1, -1. All right, it's stuck in an infinite loop now. So that was kind of a bad example. But if I increased x before I hit the continue, then it would work. Or if I did something like this, if we use the for in range statement, for x in range, starting at 1, counting up to but not including 10. Heck, I'm going to make it 11 because I want to see the numbers 1 through 10, and if I put a 10 here, it's going to stop at 9. So If x is equal to 5, continue. Otherwise, I want you to print x. And I'm going to comment this code out because I really don't want to keep seeing the input statements. So format, comment out. All right, it all went bye-bye. Good. So now when it runs, it prints 1, 2, 3, 4, 6, 7, 8, 9, 10. Why? Because when x was equal to 5, it continued, which meant go back up to the top of the loop immediately. Do not finish the body of the loop, so that's why I didn't print it out. And you don't need an else statement there. We don't have to do else there. It's not going to break it if you do. Yeah, you could put else there if it makes you feel good, but you don't have to. Why? Because once you hit continue, it can't possibly do anything after it. So this is inherently an else after that. Just like if this was a return statement out of it or a break statement. You don't have to put an else after a return or a break because that's the only option. Either do that or do that, kind of an implied else. But if it makes you feel good, you can put an else there. It just makes, you have to do more levels of indentation. Nothing wrong with doing that. I'm going to go back to where it was. I like the code example just as it was. Okay. So while true, line is equal to input. They ask for something. But if our line begins with a hash symbol, we don't do anything. If our line is equal to done, we break out of the loop. Otherwise, we print it. So why that or that? That's kind of like ignoring comments. So if I run this, it's providing me a prompt. I can type in something. It prints it out. Right, everything I type in. But then if I add a comment, it skips it because of this. The first character of the string is a hash. So this if statement is true. So it executes the continue, which causes it to jump back up here. It doesn't get to do anything after that. Right? It's a go back to top statement. And this is not a bad way to do it. I'll probably have us write code where we give it an input file, but we tell it to ignore comments. This is a perfectly good way of doing that. It's not a bad way of doing it at all. I'm going to try to tuck it away in my head. The alternative would be to do something a little bit uglier. Not too ugly. Let me paste that into our notes. Like that. But then if you weren't going to use a continue, you'd probably do this. If line was equal to comment, let's change that to not equal to comment. Then everything else underneath that would need to be indented like that. You see, that does effectively the same thing. It only gets into this code if the line is not a comment. If the line is a comment, then it would skip all this stuff. Does the same thing. And that's how I've illustrated. That's how whenever I've written this kind of code in the past for classes, that I wanted to skip hash symbols in the input file, I've always done it like that, but I'm kind of digging this one now that I see that again. So here's what they're calling definite loops, using for. While loops are great if you're like doing, you're asking for input, you don't know in advance what your input is, but if you do know in advance, if you do already have your input already stored in a list or in a file, or you can iterate through a series of numbers, 1 through 10 or 100 through 1,000, whatever, you use a for loop instead. They're calling that a definite loop. So you want to loop through a list of things, a set of things. Shouldn't use the word set there because set means something very specific in this language. But anyways, you want to go through a list of things, such as words or lines in a file or a list of numbers. When you do that, you use this syntax. For, variable name, in, and then the source of your list of numbers. The list of numbers could be a range. It could be a file name. It could be a list name. It could be a function name if you write your function very carefully. And I guess I'm going to illustrate that. It's absolutely not shown in your book, and it's not even shown in this text, but I want to show it to you anyways. we've seen the return statement. There's also something called a yield statement. And this is interesting enough that you might want to pop up idle and type it along. All right, so I'm going to make a function called dogs. The first time it runs, it's going to yield beagle. The second time it hits it, it's going to yield cocker spaniel. And the third time it runs, it's going to yield poodle. And the fourth time it runs, I'm running out of dog breeds, mutt. There we go. Yeah. So we got, what yield does is it's kind of like return. But it stores these values up so that the first time dogs is called, it returns beagle. The second time dogs is called, it returns spaniel. The third time it's called, it returns poodle. And the fourth time it's called, it returns mutt. So if I do something like this, for S in dogs, colon, print, the dog is, end quote, comma, S. It's going to print out the dog is beagle, the dog is spaniel, the dog is poodle, the dog is mutt. And if you took fundamentals, you've seen this syntax before, except you weren't calling a function. You were putting a variable or a file handle name there. But you can write functions that do the same thing. They just need to return a series of values using yield statements. And if you don't totally get that now, then that's okay. We'll probably do another in-class assignment about it at some point. I mean, mention it again in class. Alrighty. So, did it do anything? No, it did not. It stopped at 10. Well, you know what? I'm not going to worry about it if it didn't work on the first run. I'm going to take my done statement, put it down here at the bottom. Run it once more. Well, it didn't print done. Oh, it's waiting for me to enter input. Dadgummit. There. It still didn't. There we go. The dog is a beagle. The dog is a spaniel. The dog is a poodle. The dog is a mutt. Again, these input statements are giving me fits, so I'm just going to comment them out. Format. Comment. All right. And that one as well, because it's also asking for input. All right, so now actually the only thing left in our code is pretty much this little loop here. So I'm going to cut that and move it out below our commented code. And then this code right here. Right, so this counts from 1 to 10, skipping 5. This prints the list of dogs. The dogs was returned by a function. But more commonly, you're going to be doing that with a list. And I know I already just demonstrated this, but I don't see the code in here anymore about 8675. So I'm going to make a different list. How about colors? So L is equal to square brace, and we're going to list some color strings. White, comma, black, comma, orange, comma, silver, comma, aqua. Here we go. Now we're going to iterate through those values with a definite loop for S in L, meaning for every string in the list. And as always, this variable name doesn't matter as long as you use the same thing inside your loop, right? So I'm going to print S out here, and it's going to print one per line: white, black, orange, silver, and aqua. And when I say variable names don't matter, I could call this for Fred, not Ferd, for Fred and L, print Fred, right? Variable names only have meaning to us, not to the computer. I did not have to call that S. S is kind of a dumb variable name anyways because it's just 1 letter long. Similarly, capital L is a dumb variable name, but it makes for typing easy examples. Something you will see online or other programmers do, and I'm going to undo this change. This would be valid code. For dog in dogs, print dog. or we could call this colors. For color in colors, print the color. You see what's going on here? Our collective data, our list, is got a plural name, and then our iterative variable has got a singular name. And I don't type examples like that in class because every time I do, the S's start getting mixed up. It's just that it's hard to read. It's not that, you know, we're dumb or anything. It's just hard to read. So I don't do my examples like that, and I kind of tend to avoid doing that even in my professional code, although other people like it. All right, let's get rid of Fred and replace those back with S. So if you were going to make a while loop, excuse me, a definite loop that was going to add all the numbers up, we could do that. All the numbers meaning what? Let's write some numbers between square braces, and it doesn't matter what numbers they are, right? Like that. Who cares what the numbers are? You would first declare a total, and then using a for loop, you would iterate through that list, adding everything to your total. So let's initialize our accumulator. And then for, and these are numbers, and they look like integers, so I might call them I, but I think I'm going to call it V for value. For value in list, colon, add that value to total. So total equals total plus V, or total plus equals V. And heck, we may as well print out the number and the total so that we can see the values getting larger. Like that. You see, one of the things that's nice about the defined loop, the definite loop, is that we don't have to add one to anything. We don't have a counter. In our while loops, if we were going to add up all the numbers between something and something, we had to do I equals I plus 1, right? Or counter equals counter plus 1. The for loop handles that for us. It rips through the list all by itself without us having to keep track of the counter variable to use as an index. You can use a counter variable in an index if you want to do that. I guess we'll give that as an example. But see, there we added all the numbers. That was pretty easy code. Honestly, there's an easier way. Total equals the sum of L. Woohoo! I didn't even have to write this code since I had this available to me. That's kind of the power of built-in functions. The Python programmers already gave us a function for doing that, so we didn't have to write it ourselves. But you ought to know how to write an accumulating loop on your own.
Did you write a for to pick a number out of that?
Okay, pardon me?
Did you do a for loop to pick a number out of that?
Yeah, you can pick numbers. If you mean pick them out, can we treat them like it's an array and then use a subscript? Absolutely. You could do this. You would need to know the length of this list, though. So, for x in range, or for I like I for index, for I in range, starting at 0 and going out to the length of the list, colon. Then you could do total plus equals list subscript I, like that. And then we could print it out. I'm just going to go and copy that print statement. And by the way, I need to reset total equal to 0 before I go back in my loop, or else it's not going to be right. So I just added that. They both work. This is just different syntaxes. V is actually the value itself inside the list. I is an index value that you can use to retrieve the value out of the list. Does that make sense? Okay. Excellent question. In other languages, this is sometimes known as a for each loop, for each value in list. And some of them even have that syntax. They have an each word there. And I like that. This one doesn't. C# does that, for example. See what I was saying about that singular versus plural thing? They defined a list called friends, and then they wrote a loop that said for friend in friends, print Happy New Year, friend. That's great and all that. It's very clear until you start trying to type it in a hurry and you start putting S's in the wrong place and it doesn't work. So loop patterns. Often we use a for or a while loop to go through a list, and we're looking for something. We want to find the largest or the smallest value, and we want to add them up. So what you typically do is you wind up initializing a variable before the loop starts. You perform some computation on each item in the loop body, probably changing the variables in the body of the loop. And then when the loop is done, you look at the resulting variables. Like we had all those numbers there. What if we wanted to find the largest number? I'm going to make a variable called biggest, and I'm going to set it equal to the first value in the list. And still, we haven't talked about lists too much, but I hope you remember that if you have an array, element 0 of the array is the first one. And now I'm going to just write a simple loop like this for value in list, something like that. So for value in list, colon, if our current value, here, let me push this up for the people in the back row. If value is greater than the last known biggest, if value is greater than biggest, then biggest equals that value. And now we can print it out. Print the biggest in the list is, end quote, comma, biggest. And again, that's such a common operation that there's a built-in function for doing it called max. But not every language has a built-in function for handling all these list operations. So we're not going to just say always use max. Okay, so while it ran through the list, it found the largest number, 1, 2, 3, 4. And if I go and I look at my input data up here, that looks like it's likely the case. So you saw what we did. We initialized some important variable with some important value. Like earlier, we were initializing total 0 so we can add stuff to it. But this time we're looking for the biggest number rather than the sum. So we set biggest equal to the first value in the list. And then we rip through the list, checking value by value. And if that value is bigger than the current biggest, then we set that. So it's like we have a piece of paper, right? And then I have, several numbers in it, right? And so I go, okay, I'm going to just take pen and pencil and paper and write down 5. And now I'm going to check the list. Is 5 bigger than what I have here? Nope. Okay, great. Is 3 bigger than what I have here? Nope. Great. Go to the next one. Is 2 bigger than 5? Nope. Great. Is 6 bigger than 5? It sure is. So I would cross that one out and then I would set a 6 there. And then is 4 greater than 6? Nope. Okay, we're done. Now, you may have noticed, and it may bug you, that we use this number 5 twice, right? We assigned it into the total, and then we compared it. It's an acceptable slight waste of a couple of computer cycles to do in order to have this ease of syntax. Sometimes writing clear code is far more valuable than the extra couple of nanoseconds it would take to skip that first comparison. Anybody getting syntax errors that you really wish I would stop blathering about and come help? Nope. Alrighty. So counting and summing loops. This one just does a count, right? Rather than adding the variable to our accumulator every single time, we just add 1 to it, right? So every time it iterates through this loop, well, it's going to add 1 to it for that, it's going to add 1 to it for that, it's going to add 1 to it for that, that's 3, it's going to add 1 for that, 4, 5, 6. So by the time it's done, the count will be 6. We have a function for that, right? We may as well list these functions as we're going. So, x is equal to len, L gets the count of items in the list. And I'm calling them lists, and your textbook last semester, if you took fundamentals recently, called them arrays. Python doesn't have arrays, honestly, but it simulates arrays through lists. So, all right. And then if you want to get the sum of the list, like that, x is equal to sum of the list. That gets the sum, the total of the list. What if you want the maximum value of it? X is equal to max L. Don't have to write a loop, you can just use that. And it's probably more efficient than the code that I wrote. And then X is equal to min L. Gets the minimum value of the list. A couple of others. How about X is equal to list subscript 0? What does that do? Yeah, that's the first item of the list. And in Python and Python only, if you want the last value of the list, there's a weird little trick. You can set that equal to -1. And that's the last item of the list. Don't go into another language expecting that to work. In other languages, you would do this. X is equal to list, square bracket, the length of the list, -1. All right. Okay. That gets the last item of the list as well. You can see why the programmer snuck in this one, right? You know, because it's easier to type than this one. But why does this work? If you have a list of 4 items like this, I'm just going to type, you know, red, blue, green, orange. Then this is element 0. This is element 1. That's element 2. That's element 3. If we called length on it, len, it would tell us 4. But that's 0, 1, 2, 3. We can't print out element 4. So you take the length of the list, you subtract 1 from it, and that gives you the index value of the, you know, of the last value. Sure is nice to be able to do that. Oh, and by the way, if you do -2, -1 would be that one, -2 would be that one, -3 would be that one, -4 would be that one, and -5 would give you a crash, a runtime error. And if you're going from the beginning, that's a 0, that's a 1, that's a 2, that's a 3, and anything after that's going to give you a crash if you try to print out, you know, list item 4 or something like that. So technically, the way you do it is your index values for the list are 0 up to n-1, where n equals length. That looks too mathy, doesn't it? Just remember, you go from 0 up to 1 less than the length of the list. I think I'll run this to see if I've got any syntax errors in it. It's not really doing anything important at this point. Okay, yeah. And we could be printing all these values out, but you know, the comments are enough to get us going. We understand what it's doing. Here he's calling, he or she, the author, is calling their iteration variable itervar. I just use v for value, or I use the whole word value. Itervar is great as well. Just means the variable that's being iterated. Iteration means that you're traversing the list from beginning to end. Here's the same loop written, but instead of calculating the length of the list, this one calculates the length of the list because it's +1 each time. This one calculates the sum of the list because we're adding the values in the list together each time. Total equals total plus itervar, or total plus equals itervar. Maximum and minimum loops. I kind of showed you this one. They're doing it in a slightly different way. I like my way better. My way has a slight problem, though. I'm not going to mention the problem. I guess I will mention the problem. My way would crash if it was an empty list. Here's what an empty list looks like. L is equal to, what do you know? There's nothing in the list. So if I do this, biggest is equal to L subscript 0, that's going to crash. Because, remember what I said about n-1, where n equals the length? Well, 0, there are no items in it. So 0 would crash. So my code up here that relied upon that would crash. If you think you might be getting an empty list, then you would need to code it a little bit more carefully. We would take advantage of the fact that there's a special variable value called none. And then you could check that in there. If the largest value is none or it's greater than the biggest, you'd add it, or you'd set the largest equal to that. On the other hand, why not just use the max function, right? X is equal to max, parentheses list. Then you're good to go. You don't need to worry about writing your own function at all. So you don't have to worry about doing that check there. And there's other ways to try to prevent that from happening as well. But using the max function. What happens if you call max on an empty list? I'm curious about that. How could it calculate the max if there's no values in it whatsoever? So L is equal to 1, 2, 3, and then when I print out max of L, it should print out 3, right? But what if L is equal to an empty list? And then I do max of L. Well, what do you know? It crashes. Okay. So his way of doing it is a little bit better than the built-in function even. But you know what I would honestly do if I was worried about it is I would have a check somewhere up above my code. If the length of the list is greater than 0, then do all my good stuff, right? Because this is probably an extreme circumstance where the length of the list is equal to 0, right? Because you're trying to get a list so that you can process it, right? A length of, a list of test scores or something like that. But you might need to take into account that that user has not taken any tests whatsoever, in which case you could use a simple if statement. Or you could use the way that he wrote the loop here with this none. I'm not going to make you type it in. You can look at it. Then if you're going to check for the smallest value, it's the same thing, except you check to see if the smallest value is less, or if the current value is less than the smallest. And if the current value is less than the smallest, you set the smallest value equal to the current value. So debugging. As you start writing bigger programs, you find yourself spending more time debugging. More code means more chances to make an error, more places for bugs to hide. One way to cut your debugging time is debugging by bisection. For example, if there's 100 lines in your program and you check them one at a time, it'd take 100 steps, but instead try to break your problem into half. Look at the middle of the program or near the middle of the program for some intermediate value you can check. And then you check that value halfway through the code. And if that value is correct, then the problem is probably, in the second half. Alrighty. What is an accumulator? It's a variable used to hold or accumulate a result. If it's a counting loop, you could call your accumulator count. If it's a loop that adds up the sum, you could use accumulator variable called total. The counter is a variable that iterates the number of times that something happens, like in a while loop. X equals 0, while X is less than 10, something like that. So you initialize your counter or to 1 or whatever your starting point is, and then you add 1 to it each time. Or you use the range statement. Because if you do this, I'm going to get rid of that. That's some extraneous stuff. Right, so you could do for X in range 5, 11, counting by ones. Let's print out X. But you could also do that with a while loop, but it takes several more steps. X is equal to 5, while X is less than 11, print X, X plus equals 1. Those two loops do exactly the same thing. I like this one because it's easier to type. Easier to type, and it's kind of more definite. I guess that's why they called it a definite loop, huh? Because you can tell exactly where it's going to start and, barring any break statements, where it's going to stop. Right? It's going to start at 5, and it's going to quit when it equals 11, meaning that it's going to go 5 through 10. Remember that the second number needs to be 1 larger than the maximum value that you want. Or if you're counting down, it needs to be 1 less. So this is a loop for counting from 5 to 10 by ones. we can do another one for x in range starting at 20 and going down to 9 by -1. And that would count from 20 to 10 by -1s. Why would it get to 10? Because when it hits 9, it exits the loop. Just like here, when it hits 11, it exits the loop. So you either make this variable 1 greater than your maximum value or 1 less than your maximum value. Yeah, so it counted up 5 through 10, and then it counted 20 down to 10 as predicted. All right, we're getting almost too far ahead of the book. No, not really. Let's look at the online Chapter 4, Chapter 5 homework. Well, this one looks like a repeat of some stuff that we probably already talked about. Write functions to do the following conversions: feet to inches, miles to kilometer, temp F to temp C. And then write code that uses these functions. Prompt the user for a number of feet and use your appropriate conversion function. You can look up these conversions. If you get stuck on them, you can ask me for them. And then prompt the user for the number of miles and use your function to calculate and display the number of kilometers. And prompt the user for the temperature in F and use your function to calculate and display the temperature in C. I think this would be a slightly good thing to cover in class just a little bit, to make you all do something similar to this, and then for me to give you the answer after you've taken a stab at it. Because we've talked about functions, but I want to write a sample function, and then I want you to write your own function that accomplishes a very related task. So here's what I want to do. I'm going to write a function that converts meters per second to miles per hour. I'm going to have to look up that conversion. I certainly don't have it stuck in my head. And then I'm going to have y'all write a function that converts hours to seconds. Okay, so this function needs to convert meters per second to miles per hour. All right. 1 meter per second in miles per hour. Let's see if Google will tell me. All right. So that's the conversion. I need to multiply the meters per second times that to get miles per hour. Okay, so what am I going to call my function? I'm not thinking of a real clever name because it's going to have all sorts of things. I mean, I don't type this, but I could call it convert meters second miles per hour, right? That's kind of, I'm not digging that at all. So I'm just going to call this one convert to miles per hour, MPH. And then the variable I'm going to call MS, standing for meters per second. All right, the first thing I'm going to do is declare a variable to hold my result. And based on that value that I looked up, meters per second times that number happens to give us miles per hour. I'm just accepting it on faith that Google is right. And then I'm going to return that result. So now I need to ask the user how many meters per second they are traveling, and then we will convert that to miles per hour. So print how fast are you going in meters per second? Let's use input. So ms is equal to input, and then ms is equal to float ms. Got to cast it to a float. We could cast it to an int as well, but we don't want it to crash if they type in 60.2, something like that. And then we have to call our function. So we need to invoke our convert to MPH function, passing in this variable as our argument and storing its result. So what am I going to do? I'm going to call my result MPH, make an executive decision. And then I'm going to say equals, and what do I need to put here in order to call that function? Somebody knows, because a lot of y'all have taken fundamentals. How do I call a function?
Convert to MPH.
Yep, convert to MPH. And then, is that enough, putting the parentheses there? Somebody say no, because that's the correct answer. All right, what should I put there?
MS.
Right, I should put ms. Not because there's an ms up here, but because that's what I called my variable here. If I'd called that x, then I would put x here. All right, we have a result. Let's print it out. Print that equals, end quote, comma, MPH, comma, miles per hour, period, end quote, semicolon. I'll bring the code back in just a second. I'm going to try to validate that this works. Well, blew up. I typed in some bad input. Yeah. Okay. So, run it, test it, enter 1 meters per second. It should say 2.2 something miles per hour. And then take a stab at this one. I didn't give you a name for it. You could come up with your own name, but if you're feeling like, you know, having your hand hold, I could give you a name. Call the function convert to seconds and give it a shot. I'll give you the answer, you know, in about 5 minutes, but I want you to take a stab at it. It's okay if you don't get it right. That's why you have a book and study time. Possible we got it done very quickly. Oh, God. Okay, no way. Walking around and making people nervous. It's funny how much worse your typing gets whenever somebody's watching you. Which is why I can't type it worth a darn when I'm up here. You should have stopped the recording. All right, guys, I'll bring the recording back. So here's what I would do to do that. I'm going to call my function convert to seconds. That's not really that great, because what if I needed one that would convert days to seconds? But anyways, def convert to seconds, and it needs a parameter to accept the value, otherwise it can't do the calculation. And I'm just going to take my variable name from my specs here. So I'm going to convert hours to seconds. And if you've already chosen a different variable name, you don't have to change to match mine. All right, so now I need a result. And the way you convert hours to seconds is that there's 60 minutes in an hour, so you multiply it by 60. And there's 60 seconds in a minute, so you multiply it by 60 again. So 60 times 60, or 60 squared, or 3,600, whatever makes you feel good. And then you're going to return that result. So that's my function, and I need to call it. I need to ask them. Print. How many hours will you be gone? Whatever, you know, the prompt doesn't matter much. If you've already worded your question, don't change it to match mine. And then I'm going to write my my input statement a little bit more concisely. I'm going to do hours is equal to float parentheses, input parentheses. And then how many close parentheses do I need?
2.
I need 2, right? Okay. And now I can actually call my function. Seconds is equal to convert to seconds, passing in the hours, and then I can print my result. Print, you know, that equals, end quote, comma, seconds, comma, quote, seconds, period, end quote, close. And so, by the way, when I asked you how many close parentheses you need, one thing to notice is that if you get your parentheses wrong, and then you try to run it, it's not going to show you which line the error is, right? You're going to look at this and wonder for a long time what's wrong with this statement. If you ever can't figure out what's wrong with a statement, look up in the line above it. You need it to close parentheses. All right, how fast am I going in meters per second? I'm going 100 meters per second. And I can't type, so I didn't get an answer. See, if I'd made my code error-proof, I'd be a lot better off. 100. Oh, come on. All right, now we're good to go. 100, that's 200 miles per hour. How many hours will I be gone? 1, that's 33. Okay, so that works. That is a good solution to the problem. And the homework assignment that's coming up over Chapter 4, online, the online Chapter 4, is just to write some conversions. I don't give you the formulas, but look them up. If you can't look them up, you can't find them, text me. And it's not like I'm going to fail you because you got the wrong conversion right. If you only multiplied it by 60 rather than 60 by 60, you know, as long as you know the idea of a function, that's what I want. All right, so we are done. Upload your PY file or a note saying that you were here and learned something. Always do one of those two things, please.